So today we're going to talk about function notation, and I want you to be able to read and write in formal mapping notation. So I want to talk generally for a little bit about this idea of mapping. Alright, it's something we've sort of done, but I'm going to give it a bit more depth, a bit more detail today. So we're looking at a function, y is equal to 2x, right? What that is a relationship between two sets of numbers. So set number 1 will be the x values, right? So they're the x values. Set number 2 is going to be the y values. Right, so if I put in x value equal to 1, I'm going to say 2 times by 1, which is going to get out 2, right? If I put in 2, x is equal to 2, I'm going to get out y is equal to 4. So this is what's called mapping. We're mapping the values of x onto y, the values of x onto y. Alright, and this is what we're generally talking about when we're thinking about mapping. Before we move on to the formal mapping notation, I want to have a look at one other example. F of x is equal to x squared. So we're mapping f of x. We're mapping f of x onto x squared. So that can be represented diagrammatically like this. Here, so what this is, we're taking the values of x, we're applying f of x to them, we're mapping x, which is x squared, and we're getting out some values of y. Alright, so if I take 2, I'm going to get out 4. That's 2, 4 here. Equally though, if I take out negative 2 in this mapping, in this function, we're going to also get out 2. So we've mapped this guy here. This picture here is going to represent that bit of mapping that we're doing. So if we take 4, or if we take 3, it's going to map up to 9. But equally, if we take negative 3, it's also going to map up to 9. Cool, so what does that mean for formal function notation? So what does that mean for formal mapping notation? Formal mapping notation looks like this here. Right, so the mapping of x onto x squared is written formally as this. So f dot dot. F dot dot is just the name of the function. We could call that g if we'd like, but we've decided to call it f in this situation. We map r onto r. R is the domain of f. The codomain, which is a new word, is what it's mapped onto. Then we have the rule for the equation of x. So in this case, it's f of x is equal to x squared. So this guy is our domain. This guy is our codomain. And I think at this point it's important to define a couple of those things. We know by now that the domain is the set of x values, right? The x values. We know that the range is a set of, let's think about them in terms of the y values, the values that come out. Codomain is this new one. Codomain is slightly different from the range because it's the set of available y values. So the available y's. Alright. So if we take this idea of domain, range, and codomain back to this example up here, the domain for all these x values here, right? These are our range here, and in this case, that was our domain. That was our domain. Our domain in this case is going to be equal to r. We draw r with a double line, which I sort of do consistently, but need to do more of. The range is the set of y values that come out. So far we've identified that 4, 1, and 0 are a part of the range. The range will be in this case, all positive numbers, because we're never going to get a negative number for when we've got x squared, because if we take negative 3 in, we're going to get positive 9 out. So the way that we can write that is 0 to infinity. Square bracket means it's including 0. Circle bracket means that it's not including infinity, because we can't include infinity. But 0 is within the range. So what the hell is the codomain then? Well, the codomain is the available y values. So the codomain in this case is also going to be the same as the range. Alright? Because we can put negative 5 into the equation. We can put negative 4 into the equation. We can put negative 1. All of these values can be mapped under this rule. Under this rule of f of x equals x squared. Right? Those are the available y values that we can put in. But it's not the range, because when we put a y value in, we can put negative 5 in, we're going to get positive 25 out. So that would end up being the range. So I think it's often tempting just to think that the codomain is the range, right? And so you might be asked a question for this example here, what is the range? You might just say R. That isn't quite true, because as we know, the graph looks a little bit like this. Looks a little bit like this of x squared. X squared looks something like that. It's not very well drawn, and the range doesn't include these negative values down here of y. It only includes these positive ones. So to say that the range is y isn't true. Right, so we need to be careful of that when we're in question. Right, so here's an example. We need to consider the function f, where r maps onto r, where f of x is equal to a plus bx. We're also told that f of 1 is equal to 4 and f of negative 1 is equal to 6. It's going to take a bit of time for you to get the hang of this lingo. Alright, so in question 1, or part A, what we're asked to do is calculate the values of a and b and state the function rule. Alright, so to be able to calculate the values of a and b, we need to state, this is for part A, state function rule. Alright, so we need to try and solve the values of a and b. We've got f of x is equal to a plus bx. Right, we've got two unknowns here. We've got a is an unknown and b is an unknown. X and f of x are variables, but we need to find the value of a and b so we can have this rule complete in the same way that 3 plus 2x equals g of x. That's a complete rule. We need to try and work out what the values of a and b are. So what we can do is say that f of 1 is equal to, what have we got, equal to 4. F of 1, if we substitute 1 for x, as we've been doing when we're doing polynomial notation, is we say that a plus b times by 1 is equal to 4. Right, so, or a plus b is equal to 4. Careful not to confuse my b's with 6's. So that's our first equation. Right, we've got two unknowns and one equation. We need to have two unknowns and two equations. That's where this other piece of information comes in handy. F of negative 1 is equal to 6. F of negative 1 is going to be a plus b times by negative 1 equal to 6. Right? B times by negative 1 is negative b, so a take away b is equal to 6. So we've now got one equation here, two equations here. We can use those two equations to work out the value of a and b, and then substitute those back in to get f of x. To do that, I'm going to use the elimination method, because I can see that if I add equation 1 to equation 2, I'm going to eliminate these b's. Add 1 plus 2. So a plus b is equal to 4 is 1, and we're going to add that to a take b is equal to 6. So these guys are going to be equal to 10. 6 plus 4 is equal to 10. And then positive b take away b is going to be equal to 0. 0 lots of b, and then a plus a is going to be equal to 2a. Alright, so we've got 2a is equal to 10. We divide both sides by 2. And we come out with a being equal to 5. Right, we've got a being equal to 5, that's great news. Now we can use a equal to 5 to work out the value of b. I'm going to sub a equals to 5 into equation 2. Or equation 1, it doesn't matter. So we'd have a take b is equal to 6. But now a, that's meant to be b there, a is equal to 5, so 5 take away b is equal to 6. We need to try and solve this for b. What I'm going to do is add b to both sides, so I can get rid of that negative. 5 is equal to 6 plus b, and I'm going to take away 6 from both sides to get b by itself. So then b, 5 take away 6 is negative 1. So b is going to be equal to negative 1. Cool, so that's a and b found. Now you just take the rule. So f of x is equal to a plus bx. A is equal to 5 plus negative 1 x. Positive and negative in a row is going to cancel out to become a negative. So So that's our rule. Let's got part A answered. In the next part, we've got to evaluate f of 0. This should be an okay thing to do. That means that the x value is going to be equal to 0. So part B is f of 0 equals 5 take away x, where x is equal to 0. So I should have written 5 take away 0. So f of 0, 5 take away 0 is equal to 5. Got a box. And I didn't do a box on the last question either. Bad Jesse. Naughty Jesse. That was strange, wasn't it? Yeah, I'm sorry. Question C. Oop, C. This is B. In C, what are we going to do? Calculate the value of x for which f of x equals to 0. Find x for f of x equals 0. So we know that f of x is going to be equal to 0, so let's write that first. We know that f of x is equal to 5 take away x. Right, we know that this guy is equal to this guy. We proved that in part A. Equals to 0. So we need to solve now for x. What I'm going to do, I could take away 5 from both sides, but I'm going to try and eliminate this negative straight up and add x to both sides. So that means that 5 is equal to x, or x is equal to 5. So the answer to C is x equal to 5. Let's get a box around that bad boy. Part D. Find the image of negative 5. So the image of negative 5, is this is just a test of our lingo. So the image of negative 5 is when we plug negative 5 in and see what comes out. Alright, so the image of negative 5 is f of negative 5. It's equal to 5 take away negative 5. Let's be careful about negatives here. So f of negative 5 is going to be equal to 10. 5 negative equals 10. Part E is another test of lingo. Write the mapping for a function g, so we need to define a new function which has the same rule as f, but a domain restricted to r+. R+ is all of the positive values, so that's 0 to infinity, including 0, so square bracket 0 to infinity. So we head back down. What we're going to do is change the name to g. So we change name and change the domain. If we change the domain, we need to just think about whether it changes the codename. So when we write this out, what we're going to have is g, where r plus maps to the codomain. I'm going to leave that blank for just a minute, where g of x is equal to x squared, because it told us in the question that we needed to have the same rule. This is the rule. Alright, this is the domain. It told us the domain was r+, and we need to work out what the codomain is. The codomain is the available y values. What values can I put in to this function? In my mind, I can put in -1, I can put in -a bazillion, I can put in positive bazillion, so I must be able to put in all real numbers, right? So there would be our answer to part G. So a couple of definitions to finish off. Where are they at? Domain. The domain is the values available to put into the function, not the range. Let's be careful of that. I remember I always stuff that at school. And then mapping and image. The process of putting numbers, mapping is the process of putting numbers into a relationship and getting a value out. E.g., when 5 is mapped onto h of x equals to 3 of x, the image is h of 5, which is equal to 3 times 5, substituted 5 in, which is equal to 15. Alright, don't be too intimidated by this, just practice the relevant questions. You'll be sweet. Good stuff.